Well, our launch for tomorrow at the Hughes farm has been canceled due to high winds. So I'd like to talk about something else. I'd like to talk about keeping your nose cone. And when you're dealing with Kevlar cord has no elasticity to it. So when you use it in your injection system, if this is tied to the rocket, the nose cone comes out and gets a really powerful snap on the end. Now, this is a trade-off. If you use an elastic cord, it's going to stretch out and it's going to stretch back and damage your rocket. So we have to dissipate this force somehow. If we look at some of these other Kevlar cords, like this one here, this is very, very thin. So with that amount of force and these thin cords, these cords tend to tear through the nose cones. So we got this problem of how do we keep the nose cones from tearing off? That's a little bit of a problem. If we look at this, here's an example nose cone, and we can see that, well, the entire eyelet just simply tore right off. I've seen different types of damage where either the eyelet splits in the middle and the cord slides out, or the entire eyelet tears right off. So let me show you some solutions that I have for fixing this. Okay, this is a high flyer. It's a very nice rocket. I've launched it many times, and I've gotten some damage a few times. In this particular situation, you can see the damage was that the eyelet tore off completely, and what I did was to replace by putting a toothpick across where the eyelet was, and I coated that with plenty of CA glue. This whole area is coated with CA glue, and I've not had any problems since then. So again, this eyelet tore off, but the reason is that this nose cone has some clay in the nose. Whenever you have a heavy nose cone like this, and this nose cone shoots off from the ejection charge, this cord puts a tremendous snap, and that little eyelet usually does not survive. So again, this survives a lot better. A wooden toothpick on both ends with a lot of glue and the Kevlar cord. So here's another example. This is my Wizard rocket. Now this nose cone is the same as a high flyer, but it does not have any weight in it. However, just to make sure, on this particular nose cone, the eyelet is not torn off, so I decided to reinforce it just to make sure it doesn't. And this was done by putting a toothpick across this. I put the Kevlar cord around both the toothpick and the eyelet, and I covered the whole thing with just a lot of CA glue. The CA glue is nice because it's very good. It'll soak into things, and it dries as a nice solid unit. It's really, really nice glue to use for stuff like this. So again, once the snap hits this, it's now got this extra reinforcement so it doesn't cut through. And again, sometimes the cord just slices right through. This is not going to slice through now. Now this is my zero gravity rocket, and I use a slightly different approach for this. For this one, again, I want to make sure I make the nose cone loop stronger before I fly it. I don't want it to tear off and then fix it later. For this particular one, the nose cone came in two different parts, namely the top and then the base were separate. They had to be glued together. But what I did on this one is, since the base was separate, I ran the Kevlar cord, it's a little hard to see with the rest of the stuff there. I ran the Kevlar cord first through the base in two different places. So the Kevlar cord now is attached in three separate places, on the eyelet and then twice in the base of the nose cone itself. And this then allows the nose cone to dissipate more of the energy across multiple loops on the Kevlar cord. Again, the whole idea is to increase the strength because that loop is just not enough. So it's another example of my Kasai rocket. This one these are a BT50 nose cone. The other ones were the smaller ones. This case, what I did is I just simply cut the eyelet right off. And then I drilled a hole into the nose cone, and then I just fed that through and connected the Kevlar cord there. Now, this was a slip line knot. I just put the slip line knot through, pulled the knot tight, and then I coated this whole thing with some CA glue to make everything nice and tough. But you can see this time the Kevlar cord it has this entire nose cone area, and it's not going to tear through that. So this is another custom rocket. This is an interesting, very fun design to fly. If you look at what I did on this one, similar to the other one, I cut off the eyelet because I know that's fairly weak. I drilled a hole near the bottom, and then I fed the Kevlar cord through. So this one just feeds the cord through a new hole and through the hole on top. A little bit of CA glue on top to lock the knot in place, and now it's nice and solid, and it's unlikely to tear through. Again, this is going to be extremely strong compared to the eyelet, which usually tears off in many situations. So from a High Flyer XL, with the bigger nose cones, and tear off is going to happen a bit more with the bigger nose cones as well because they're fairly heavy. What I did on this one is that I drilled a hole on either side of the nose cone, and you see I just cut the eyelet right off. I had no need for this. And then I put the Kevlar cord between the two holes, pulled it tight, and put a drop of glue on the end. So again, a much more strength than just the simple eyelet alone. So this is my junior Bertha, and I did a similar thing again. If you look at the nose cone, in this case I didn't even bother using the eyelet, I just left it there. And again, I put a hole on either side of the nose cone. I put the Kevlar cord through, and then after I put the cord through, I pulled it tight with a knot, and I put some CA glue on the knot to hold everything together. Okay, I'd like to take a look at my Lock Precision a rocket here. This one is the right here, the high tech. What's interesting, this is a payload rocket. As I commented before, if this gets heavy, it's going to put a lot more force on the actual cord. So we open this up, we'll see what happened on my last flight. We'll see that the Kevlar cord was around it. This is a metal eyelet, this is steel. So it's extremely hard, just very, very tough. But yet the Kevlar cord put so much force on this when it yanked on it, it literally bent it right open, and then it popped off and it went sailing a different direction. So again, when you're dealing with altimeter rockets, the altimeter payload bay, in this case, is fairly large. It's going to be heavy. And that cord is going to put a big, big snap on this, and it's just going to tear things apart. So again, you have to be careful when you get to heavier nose cones, such as nose cones with clay or nose cones that are heavy or payload bays. All of them need to have much, much more reinforcement when you're using Kevlar cords because there's no elasticity. Okay, I'd like to also comment on another payload rocket. This particular rocket is called a Payloader 1. I had one of these, and the payload section unfortunately tore off. It floated away and I lost my altimeter. As I built my next two altimeter Payloader 1 rockets, I did a little change on this just to make sure. And it's the same thing, a significant reinforcement of the attachment point of the Kevlar cord. So you can see where the Kevlar cord is attached. What I've done is I've actually added toothpicks on either side of the cord, or the eyelet. So the cord goes through the eyelet, and then at this point, these two toothpicks are glued on either side. And doing that, I coat the whole thing now with CA glue, and that makes it extremely strong. If you think about it, this entire payload bay is like a giant bullet being shot out of a cannon, and you have to stop that motion with a cord that has no elasticity. So this is a tremendous amount of force that happens on these particular payload rockets, and you really have to reinforce this if you're using the Kevlar cord. They might ask, well, why not just put an elastic cord back in there? Well, the same problem is that the elastic cord will be receiving the shock, but then it's going to transfer the shock back by snapping back, and that usually results in tangling, damaged parachutes, or in many cases I found, if this just snaps right back, it's just going to tear the rocket, it might zipper it. So again, you've got a different set of problems to deal with. This problem is a little bit easier to deal with because it's just reinforcing the connection of the Kevlar cord, and you should be in pretty good shape. Okay, if you've been following this channel, you know that I try to engineer a better solution on the rockets, namely make them safer, make them fly better and much more durable. And you can see one of the biggest problems I have with using Kevlar cords is their lack of elasticity. It tends to tear the nose cone off. Now it's going to depend on your type of rocket, your size of your nose cone, how heavy it is. But if you're going to be working with Kevlar recovery systems, you have to always work on the fact that there's going to be a lot of stress on that nose cone when it gets shot out, because you're basically shooting a nose cone out of a cannon and you're trying to stop the bullet with a cord. So again, use some ingenuity, figure out how you're going to reinforce your nose cone. Sometimes I use toothpicks, sometimes I drill multiple holes, sometimes I put it across the base. Again, use some ingenuity here. And I seldom use the actual little eyelet itself. I usually just cut that off or just ignore it, simply because I've found that sooner or later it's just going to tear off. So go ahead, make your rockets a little bit better, a little bit more reliable, and have fun.